How might we go about evaluating a complex rational expression? For example, we might wish to evaluate this complex rational expression when x equals 3. And in order to do that most simply by hand, we're going to break this down into a few steps. Namely, first we'll evaluate the numerator, then we'll evaluate the denominator, and finally we'll put them together. So in this example, to evaluate the numerator, right, our numerator is 3x minus 2 over x plus 1, and we're plugging in x equals 3. So we'll have 9 minus 2 is 7, 3 plus 1 is 4. We'll have 7/4. That fraction is already in lowest terms, so we'll just leave it like that. To evaluate the denominator, well, we have x plus 4 over x minus 2, and we're plugging in x equals 3. So 3 plus 4 is 7, 3 minus 2 is 1. We get 7 over 1, which we'll just write as 7. And now we put them together. What does that look like? In our numerator, we have 7 over 4. And then in our denominator, we have just the number 7. So we're going to put these together, we just interpret this main fraction bar as division. So we have 7 over 4 divided by 7. So that's 7 over 4 times 1 over 7, and that's 1/4. So when we evaluate that rational expression, our final result is 1/4. Now, one quick thing to notice. It's important to keep track of which one is the main fraction bar, right? Because, for example, if we have 7 over 4 all over 7, that's different from 7 over 4 over 7. In the second case, if we did 7 divided by 4 over 7, that would be 7 over 1 times 7 over 4, which would be 49/4, right, which is clearly not the same as 1/4. It's important to keep track of which is the main fraction bar. You'll notice that I've been doing two things to keep track of that. I've been drawing my main fraction bar really big, and I've been allocating the same number of lines to the numerator and to the denominator on my paper. If you find that you're losing track regardless, you can always put your numerator or your denominator or both in parentheses to help you keep track of which is which.